Okay, so this is my first interview for Project 3 in writing class. And so the person I'm interviewing is my dad, Lynn Lohman.
Hello.
He has been a mechanical engineer for
29 years at Ford.
Yep, so I'm going to ask him some questions about that. So, how do the principles of science and mathematics apply to your everyday task at work?
Well, we design parts for cars, specifically the chassis. Those are the suspensions, the axles, the frames. And so basically we're designing, understanding the loads that go into these parts and calculating the stresses, choosing the materials that are appropriate, and then designing. In addition, you design to meet corrosion requirements, and from different environments they may be controlling, they may be operating in, and then there's some kind of life cycle. Maybe at Ford we design for no issues for the first 10 years or 150,000 miles of operation. So use up principles of science and mathematics to answer all of those.
Okay. Is it true that despite that you studied upper level science and math while at the university, you could more than likely end up like a program manager using different skills to what you learned?
Well, it's not that you end up as a program manager, but you're at Ford. There are a lot of different positions to fill, so that you could, if you did not want to do much program management, you could pick a job that's specifically, heavily math-based work, like CAE. Those guys just do computer simulations of different parts, so they don't do much program management. My job, it's probably about 50-50. Half of it is designing parts, half of it is managing the programs, measuring its cost, timing. So working with the plants, working with, come on, take this seriously.
I just edited it out.
We work with assembly plants for the assembly. We work with our service groups for repairing.
Okay. So, mechanical engineering is a broad field. What is your area of expertise?
Just stop it.
Oh, I can just clap it up. Let me re-ask it. Okay. Mechanical engineering is a broad field. What is your area of expertise?
I work in the automotive field, and I work in chassis design. So that's designing chassis parts, shock absorbers, coil springs, leaf springs, control arms, bushings. We design parts and release them for production.
Okay, what importance does your position have on the everyday person like me?
So that's what's fun about this job is we design cars and trucks which people buy and use every day. So when you get in a new car, you'll feel the effects of the engineering that goes into it. And it's for chassis. Typically, it's the ride, the NVH, the handling. Those are all things. Those are kind of the main outputs. And then, if we're done our job right, you should have no problems with those components either.
Does the consumer in the world market have an effect on engineering as a whole?
Yeah, I wasn't quite sure exactly what you meant by this question, but when I think of a world market, we are more than ever now, we design a product that can be delivered into markets around the world. So something I design here that's used in the United States may also be used in Europe, South America, Russia. So those environments are different. So yeah, it has an impact on all these customers, and you have to look at sometimes if there's like in Russia, sometimes a particularly cold area, you may design a unique part that just can, because of the expense of designing a unique part for a cold environment like that, you may have a unique part that's used just in Russia, not in the United States. But so yeah, that would definitely a world. It's a world market, and it affects how we engineer our products these days.
With the improvement of motor vehicles, is the joining of mechanical engineering and programming a vital part of future cars?
Oh yeah, we're more and more integrated now with our electronic steering, brakes, all the safety or the safety aspect of brakes and computer um, application of brakes for roll stability control. But the one thing you probably have seen on commercials with Ford now, we have a parallel parking assist. Have you seen it where the car pulls up, you push the button, and then it parks itself. It parallel parks itself into a spot.
Mm-hmm.
All that's part of programming that guys work on.
Okay, as the United States continues to look for alternative power sources for motor vehicles, do you think there's a strong future in electric and hybrid vehicles?
Definitely, that is the future. I would anticipate, and you see the vehicles out now, and they're going to get better and better. We have to meet the government's put out standards for average fuel economy requirements, and they're going up for your fleet. You know, the average fuel economy requirements for a fleet that a company produces, and this is electric and hybrid vehicles are a way of meeting those requirements. So I think you'll see it more and more in all of our vehicles.
What consumer group do you think will buy these electric and hybrid vehicles?
Well, you know, currently it's mostly people looking for maybe something a little bit unique, a little bit different, that's getting them either improved fuel economy, or they're not buying gas at all if they're buying electric. And they're kind of unique. It's a small group of people, but I think you'll see it expand more and more as the capacities of the batteries improve, or the efficiencies, and prices start to come down a little bit.
Do you know of any other alternatively powered vehicles that are being investigated?
Another popular powertrains, that people are looking at now is hydrogen power. So it's good. It's interesting in that, the emissions is virtually nothing. Some water comes out of the tailpipe. Hyundai actually has one of these cars in production now. That's just coming out. So that's something that is probably going to give the electric and hybrid vehicles a run for their money.
How do you think society ranks engineering compared to other professional disciplines?
Well, I think it ranks them high. It's a very hard discipline to get through school. It's difficult. Maybe not quite as difficult as being a doctor, but it's difficult, and they do a lot of important work. They're designing buildings and bridges and powertrains and cars and trucks, everything, even medical supplies. All that stuff is designed by engineers.
If you look at your career so far, would you say you made the right choice?
Oh, it's definitely been the right choice for me. I was fortunate to kind of grow up in a farming environment, so I had a lot of hands-on experience with fixing cars and trucks and tractors and that kind of stuff, but I really didn't understand the engineering side of it. So I knew I could repair things, like a mechanic would do, but I didn't really know too much about engineering or what that even was. But in high school, I had a physics and a math teacher who both did, and they kind of helped me see how you could kind of marry those two. And so it's been a perfect match for me.
Okay, if a person wishes to enter your field, what characteristics must he or she display?
Well, to get through the classes, as you know, you need to know, enjoy doing the math and working on the physics problems. But I think what you need more than anything is just the willingness to work hard and stick with a project. It's easy to start something, and then about halfway through, when it gets a little tough, to quit. And so you really, and that's the same way in work. You start lots of new projects. They sound exciting when they're new, And then you start to get in the middle of the project, you start to get into some of the difficult things where things aren't going right, changes have to happen, and you have to be willing to be a person who keeps working and not give up and keep pushing and keep trying and experimenting and get to the finish. So you have to be so if you've got that drive to start something and get it all the way to the finish, as opposed to losing focus in the middle and quitting, then you can be an engineer. You can work in that field.
Is there any link between different forms of engineering apart from science and mathematics?
Yeah, I mean, it's whether you're working on a bridge or a train or a building, essentially you're designing the parts. You're usually probably working with a team of people, and these teams have different individuals that have different skill sets. You're working within a certain budget, and you may be working on a global scale as well. So whether it's a coil spring or a window or a solar panel, that's beside the point. The process is probably very similar, no matter what the part.
What does an average day consist of for you?
So my day kind of runs from 7 in the morning to 4:30. So I kind of like to work 4 hours in the morning, take an hour and a half for lunch, which is usually when I exercise, and then 4 hours after that. So my day is kind of broken up between, I spend most of my day of my 8 hours of work will be spent working on a forward model project. Right now I'm working on a 2017 and a 2020 vehicle. So most of the day is working on that, supporting that vehicle, whether it's designing the parts, working with the suppliers that'll be making these parts for us in production, working with the assembly plant to how they'll be assembled, working with our service group to see making sure that they can be serviced by mechanics. That takes up most of my 8 hours. That's probably somewhere in the neighborhood of 60% of that time for that. The other 40%, 20% of it is working on maybe current issues on current production parts. So like we're making our 2015 vehicles are being assembled right now, and 2016s are being going through pre-production phases. So maybe there's an issue, a warranty issue out in the field. Maybe there's an assembly issue at the plant. Maybe there's a part issue with the supplier. They're moving their manufacturing from one spot in Mexico to another spot in Mexico, maybe. Or maybe they're getting a new machine in, or maybe something broke and maybe they need a new material. There's lots of different things. And then there's also the other 20% is probably working on improvements. Sometimes parts go, you're always working towards a deadline, so a part has to meet this deadline to go into production. Sometimes you don't get a chance to optimize it the best you can because you have these deadlines. So once you're in production, then you can go back and look. You'll see maybe a few opportunities where you can say, you know what, I think we can maybe take a little material out of that part and save 50 cents a part, and retest it and bring in a design change that's for a part that would be a little bit cheaper. 50 cents doesn't sound much, but when you use it on 300,000 vehicles or 50,000 vehicles, it adds up to quite a bit of money. So that's probably the other 20% of my day. And then kind of weaving in all of that is just constant communication with purchasing, testing, suppliers, whether it's emails coming in or phone calls and meetings that you have. So it's a very full day, and you start at 7 and you blink and it's lunchtime, and you blink and it's 4:30 and you're running home. So it's never dull.
What has been your most meaningful accomplishment in your field?
Well, I've worked on chassis components most of my career. Different products have taken me. I've got to see a few different things. I've worked on one vehicle line that was built in Brazil, so I got to go to Brazil for a little while for that launch. So I've been to a few different countries because of my job, but about halfway through, maybe this is about 10 years ago now, we were redesigning front and rear stay bar systems for a new vehicle. We were able to take out a few parts, make this system with a few less parts, so a little more efficient, much cheaper, a little simpler, and I see that go into production, show up on dealerships all around the United States, and that design is still in production today. So it's still going. And so now that we've been able to take those same concepts and kind of apply it to other models. So it seemed a little risky at the time when we started, but we said, what the heck, let's try it. And it's worked out, and it's worked out well. We're actually expanding it to more model lines now. So,
If you were to move to another country, would it be easy to adapt to their standards of engineering?
So that is interesting because at Ford, we used to have two branches. We had Ford of Europe doing engineering, and we had Ford United States engineering their cars. We were building very similar products, but completely different. And so now, after our One Ford initiative, one area is designing a car for both places. And so what we've seen is, we had slightly different standards. So we've been marrying these test requirements. And they're very similar, but they were a little bit different. And so we kind of argue or debate them and come up with one now. So we've gone through that in a lot of cases, and it's not hard. It's not impossible, but you do see those differences. Everyone has a slightly different. These different countries or engineering sources do have different, slightly different requirements that you have to think about.
Okay, what would you say your key tasks are in your organization?
So my key task is really about designing a part to support launch of a new vehicle. So I design the parts.
Is there interdependency between different departments in your company?
Yeah, I mean all these departments, whether it be purchasing, finance, program management. We have another part of our company called STA. They work with suppliers to make sure they've got the best quality plans in place to get us a quality part. But it all kind of branches off from the design of the part. So the engineer designs the part, he works with purchasing to find the right supplier at the right price. He works with vehicle operations, which is our assembly plants, to assemble that part. And he works with quality guys. So it's all these pieces work together. It's not really one person on anything. It's just it's 5 or 6 people pushing through. It's this team of people kind of working on these parts to get them all to a job one launch.
What do you think is going to become the biggest challenge for engineers in the future?
So it's hard to tell, but to me it seems like we're really pushing to get improved miles per gallon out of cars, which means what are you going to do that? Well, you can make cars really small, and that's what was done in the 70s. Cars got a lot smaller, and they were very low horsepower, so they weren't very fun to drive. And now cars have gotten, there's been a lot of weight added to cars for safety features. Cars have gotten bigger, engines have got a lot more horsepower. Cars are really nice, but they need to get better gas mileage. So one way to do that is make them lighter, and that's to me going to be the real challenge, to get the weight out yet still meet all the customer requirements.
Okay, do you believe that long-term sustainability, a healthy ecological system, is going to be ensured by engineers?
Well, some engineer is going to be the one who, is going to be the one who has a good idea that maybe maybe changes everything. But it's really going to take a big team of people, right? It's not going to. Engineer may have an idea, but it may be that helps with the sustainability. But it's probably going to be a lot of individuals, not just one big idea. It's probably going to be a lot of little ideas that working towards meeting more sustainable, materials that are renewable that you might be using. Guys in the tire areas are doing a lot of stuff um, with that. So engineers are going to be a key part of it, that's for sure.
And last question, who was your role model engineer when you were young?
So I grew up in a small farm town. You've been there. There's not a lot of engineers around. There are no engineers in that area. So unlike where you grew up, where you're surrounded by people that were engineers. So, I had my parents, my dad, my grandpa. They were all kind of hands-on farmers. Fix it yourself. If something broke, you had to fix it. And so that really got you introduced to machining and welding and using the tools and nuts and bolts and how this part goes into that part and gets bolted up. And so that's really priceless when you think about engineering, because that's not something you can get by going to a local university. That's just life. But so that was really kind of my role model on one side. Then the other was my math and physics teacher that I mentioned before. They really were the kind of showed me that you can either be more of a mechanic that takes the part, puts the parts together, bolts them up, takes them apart, or you can be the engineer who decides what size bolt to use and what the shape of the part should be and what material the part should be made out of, and what radius should be on that corner to make it the most efficient. So a little bit different maybe than growing up in a big city, but ultimately I think a good fit.
Okay, well, thank you for answering these questions. Good interview. So, yep.